I repeat, the first step is we need to define ourselves what are the axes. The axes here, I'm going to make horizontal to the right as X and vertical up as Y, implying those are the positive direction. Now, after that, we are going to break each forces into the axes that we have defined. The rule is we're going to use the Fx and Fy for each forces from 1, 2, 3, 4 that we have defined this. The angle theta, however, should be defined between that forces with the x-axis. So on force number 1, we don't have the theta because it is already on the y-axis direction. No need to break it up. Force number 2, we already have the angle. Force number 3, we also have the angle, even though it's unknown, but it's defined already. Force number 4, unfortunately, we cannot use the number that's given here because it is between that force and the y-axis. We need to be the one in the x-axis. So we need to calculate it first. Once you have this, the next step will be to make up their component. So F1y is directly 40n. Okay. F1x is simply 0. You can omit them, or you can write them if you want to be complete. Next, we're going to have F2y. That's going to be 30 sin 20. Okay. And F2x is going to be 30 cos 20. F3x is going to be P sin, X is cos. P times cos theta. F3y is going to be P sin theta. F number 4 on the x-axis is 17 cos 35. And F4y is going to be 17 sin 35. Up until this, any question? No? If no, then let's see numbers. Okay, today is the 6th of May. So that's going to be 1, 2, 3, 4, 5, 6. Eugene, get me these numbers. Okay. This is Eugene, and then Farrell, and then Felicia and Geraldo.
Sir, Felicia is in the toilet.
Okay, thank you. How do you know, by the way? You didn't put any camera in her toilet, right?
No, she asked me to told you.
Oh, okay. But why did he told you and not me?
She said that she's in a hurry.
Okay. So, while waiting for the Felicia, all the others, can you do your part?
Mine is 30.
Farrell is 30 point. Give me 2 significant figure. 07. Okay, 30.07. Okay, anyone else?
Mine will be 29.2.
Wait. Okay, we'll do it alphabetically. E before G. Okay, Eugene first.
29.2. You want it in 3 SF, let's say.
Oh, sorry. 2 decimal point place in this case.
Oh, 29.21.
Okay, good. Then, Geraldo?
9.75. Mine the down one, sir.
Oh, sorry. 9.75. Okay, Felicia, has she come back? Not yet. Okay, so we'll skip for a while, and Joe, take over her place.
Okay, wait, sir.
I hope everybody prepare with the calculator, yeah.
13.9.
9 what?
2.
Now, in this case, we need to also know what is being calculated here. So this is F1. Practically, it is F1Y. F1X doesn't exist. It's 0. It's nothing. Now, F2 here is this. This is F2 on the x-axis. It's going to the right. And F2 on the y-axis is going down. The 32 sin 20 seems a little bit too big. Can you guys check this? Eugene, can you check 32 sin 20? I think that 29.21 is a bit too big.
I think mine's, oh yeah, mine's on radian. Hold on, sir. Forgot to change it back. 10.94.
10.94. Okay. Okay. Next, after this, we also know what is this. This is going to be F3 on the y-axis, and this is going to be F3 on the x-axis. Okay. As of 4, we're going to break them here. F4 on the y-axis, and then another one, F4 on the x-axis. If this becomes too complicated, my suggestion will be to redo it again on a clean condition. So here I'm going to add here, up, we have simply 40. This is F1Y. And we also have up from F4Y. That's going to be, what's that? 13.92. So I think I'm going to have them here. 13.92 and up 40 for going up. For the going right, there's only one, and that is F2X with the magnitude of 30.07. Going down, we have two. F2Y, which is, where is it? F2Y 10.94. And also, we have going down here, P sin theta. We don't know that. We don't know the number yet. Going to the left, there's also two. We have F3X, which is P times cos theta, and F4Y, F4X, sorry, F4X 13.92. Okay, so here it is, the condition, now that we have broken down into the axis. This is the third step. Any question for this? Everybody okay? Now, once we have this here, we can make the equation for the axis independently. Because they're in equilibrium, all the forces in both axes totaling 0. We're going to formally write them. Sum of the forces on the x-axis is going to be 0. We can either use positive and negative, or in this case, because we know 0, we can use left and right. So I'm going to use the left one, P cos theta plus 13.92 equals 30.07. From this, we can calculate that P cos theta is 30.07 minus 13.92. Okay. Has Felicia come back? Hello? Felicia, are you there? Not yet. Okay, it means Karen, give me the number.
16.15.
16.15. Okay, so that is P cos theta. On the other hand, sum of the force on the y is also 0 because it's equilibrium. And we can say going up equals going down. 13.92 plus 40 equal P sin theta plus 10.94. So 13.92 plus 40 minus 10.94 will be P sin theta. So P sin theta is, Kevin,
42.98.
sorry,
42.98.
42.98. Okay. I think, okay. F1x, F2x 30. Let me check again. Something is not right here. Wait. 30, 40. Wait. Well, sorry for the interruption. I'll go check. Let me check again. 40 up. Okay. F4. Oh, 9.75. I think we make a mistake on the number here. F1y here. F9.75. Sorry. Okay. Can you do the calculation, please, Kev?
Oh, wait. So it's 9.75 plus 40 minus 10.94, right?
Yes.
That'd be 38.81.
Thank you. Okay, now we have the component. We can calculate the P and theta easily. Okay. The P will be using the Pythagorean theorem, the square root of 16.15 square plus 38.81 square. Okay, who's next? Natalie?
42.04.
Okay, in this case, we can round them into 42 Newton. Good. Next, we know that the tan theta is going to be P sin theta over P cos theta. Or we can turn them into theta is tan inverse of P sin theta over P cos theta. In number, that's going to be tan inverse of 38.81 over 16.15. Okay, next. Michelle? Hello? Michelle? Is Michelle here?
Yeah. 67.4.
For the accuracy of angles in degree, that's going to be 1 decimal place. For radian, that's going to be 4 decimal places. Okay, that's it. For 6 mark, I think this rather short answers, rather short question. Any question for this? Anyone would like to have explanation on how to do it? Can I know which one of you is confident that you do this correct? Please give me this if you think you're correct on the essay. Anyone? No? How? Okay, good. Others? Give me this if you think you have at least halfway, more or less about halfway. None? Okay then. Let's go to the third question. Why third? Because practically it's the same thing here. So what we do is we are going to get the axis. This is X, this is Y. This is pretty much standard. Okay, the thing here is the question did not give explicitly the forces. Imagine if you have a point here, let's call the point T. The point T is going to be pulled into two directions, going there, 20 Newton, and going there, 45 Newton. Sorry, 40, that's going to be T Newton, my bad. We don't know T yet. What about the angles? Now, if this is 60, then the angle here will also be 60 degrees. So this is going to be at 60 degrees. And this is going to be 45 degrees for the same reason. Now, M here, it doesn't show any thread at all, but we should understand that they are going to be pulled downward. The point T is going to be pulled downward by the effect of the weight. Okay, I'm going to call this W, and that's going to be M times gravity. In mechanics, gravity is taken as a constant 10, and that's going to be 10 M. Okay, up until this, any question? No? If there is no question, then we're doing the same thing here. I call this force number 1, this is force number 2, and this is force number 3. We are going to list the component in the X and Y direction. So, F1X is going to be, who's after Nisel? Leon. Give me what is F1X.
Sorry, which one, sir?
F1X. This is F1, but we are going to break them into X and Y direction. Follow the pattern here. This pattern.
20 cos 60.
20 cos 60, and give me number. Hello?
It's
Leon.
10.
10. F1Y is going to be Nicholas. Nicholas. This is going to be F1 on the X. Now we go F1 on the Y. Nicholas, hello. Is Nicholas here? No? Shuffle then. Shuffle.
17.3. Yeah, 17.3.
Give me the calculation first, just like
Oh,
Leon.
20 sin 60.
Okay, and that is
17.3.
3 what?
32.
Good. Next, the F2 we have only on Y direction. That's going to be M times 10 or 10M. That's it. There is no F2 on the x-axis. Now we have F3 on the x. That's going to be Tessa. Tessa, give me the calculation and then the result. Hello? Tessa?
Yes, sir.
Brandon, get ready. Give me what is the component, what is the F3X? This one on the X direction.
T
You
cos
might use
45.
symbol here in this case because you don't know T cos 45, and we just need to calculate the cos 45 because we don't know what is T. What is cos 45 then?
0.707
0.7.
P.
Okay, good. F3 on the y-axis. Brandon. Brandon, are you there?
Yes, sir.
Okay, give me F3y.
FE. Oh, F1.
F3 on the y direction. Are you not following me before?
Oh, F3Y.
See the pattern?
T sin 45.
Okay, and the result is? What is T sin 45? Hello?
0.7070.
Okay, good. Now we have them here. Okay, as usual. Let us rewrite this in diagram. Usually, I follow diagram help me. Let's start F1x first. F1x, the value is 10, simply 10. And then F1y going up, it's 17.32. Then F2y, we go down, it's going to be 10m. F3 on the x direction, we have here 0.707 of t. And the last one, F3y, when we write them, it's going to be going up 0.707 of t. Now, we can practically forget the original question here, because our diagram will be able to answer the question now. With this, we're going to have the summation on the axis. Sum on the x-axis is simply 0.707. T is 10. So what is T? Christopher?
14.1.
14.1. Now, sum forces on the y-axis is going to be 0.707 T, but we know T now, plus 17.32 equals 10 M.